Dear students, welcome to the Nanotechnology and Nanomaterials course. This is Dr. Parvati, working as professor in EC department. I'm having teaching experience of 23 years. My PhD specialization is in VLSI design, in which embedded memories SRAM testing. The subject nanotechnology and nanomaterials represents the manipulation of matter at the atomic or molecular scale. In the second unit, you'll be having carbon nanotube separate topic that is represented in unit 2 PPT differently. So this unit is taken for both unit 1 and 2 together, except carbon nanotubes. So the contents, if you see in this PPT, are like introduction about nanomaterials, then the material types of materials and making of types of materials, features of nanostructures, application of nanomaterials, and technologies with which they will be developed, and nano dimensional materials, zero dimension, one dimension, and two dimension structures, examples, their size effect and fraction of surface atoms, then specific surface energy, surface stress, and effect on the lattice parameters. Then it is continued to density of states, then synthesis procedures like bottom up and top to bottom approaches. Then precipitative, reactive, they like synthesis processes for making the nanomaterial. Then scaling while preparing the nanomaterials and their potential use, everything are seen in this first PPT. So when it comes to nanotechnologies, basically the materials are very precise, and with respect to size, everybody knows that nano in the sense very small. So application with compact size, not only compact size, it's also application with respect to low power or device parameters, and the dissipation current or everything will be very of nano scale. And so the subatomic molecule level, the material will be made. So nanometer scale will be considered even atomic subatomic level. So to produce a nanomaterial, we require a fine type of material, fine quality or fine quantity of material, and the characteristic properties of such fine quantity is very essential to capture. So why nanoscale? Why not other? If you observe that nano in the sense, everybody aware of that, 1000 of millionth of a meter. So basically, compact nature is interesting of every people, applications, devices, or anything. So materials of nano are different comparatively larger scale materials. So as the technology is growing, nano size have taken lead, taken importance. So every material, every device is made up of nanomaterial. Gradually, gradually nanomaterials have taken importance, and this is the scale. If you observe that from 10 to the power of 6 nanometers going towards left hand side, 10 to the power of 5, 4, then 3. So 10 nanometer, when it comes to 10 to the power of 0, 1 nanometer. So down to the scale, it is written in terms of from the nanometer, micrometer level, nanometer, reaching to nanometer towards left hand side. And the examples for at each every nanometer, see, for example, at 10 to the power of 0, 1 nanometer, the DNA diameter is of that size, and protein is of size of 10 to the power of 1 nanometer, that is 10 nanometer. Similarly, 150 micrometer human hair is of diameter 150 micrometer. Similarly, the grain of sand, if you observe the sand, a small particle of sand is of 1 mm. And similarly, within the human blood cells, red blood cell size is of 10 micron meter. And transistor, the one which will be used in the ICs and all, is of size 35 nanometer length. Similarly, above which carbon nanotube diameters, that is 5 to 10 nanometer. It is one kind of polymer and have got many applications. Nowadays, people are using in preparation for the batteries and semiconductor materials alternative to the mass transistors, where size reduction is important, right? So, similarly, atom, if you see the very least sized atom, 0.1 nanometer. So, like that, as you go down to the size of the particle is getting reduced, and it is essential to understand how important a nanomaterial. So, nanotechnology basically defined in such a way that a molecular or macromolecular level in the length scale, approximately 1 to 100 nanometer range. And similarly, at the system level, when you use nanotechnology based device for making the system, so the properties and functionalities are a bit different compared to larger scale. And generally, when you go for nanomaterial, the system which is made with nanomaterial from the scratch, from the atomic level, one should take care of the device characteristics. So this is broadly brought to you to see that nanoscale contaminants generally that we see, we regularly encounter in daily life. And see, these red markings are horizontally represented, which are types of filtration. So, and the upper arrow down were shown, which are nothing but the types of particles which are that size of nano size. And then so filtration methods, if you see, one is conventional method, and then using this conventional method, pollens are like the flower, outer parts of the flower, the tiny central particles of pollens, a small dust particle like that. So those of a size of 10 to 100 micron meter can be done using conventional filtration. When it comes to aerosols, it requires, because the size of the aerosols is 1 micron meter, so it requires a particular method of filtration, that is microfiltration. Similarly, when it goes down to another technology level, 10 nanometer to 100 nanometer, so their filtration is ultrafiltration is required. Similarly, when it comes down to still tiny particles, zero point 0.1 nanometer to 1 nanometer, the filtration is reverse osmosis method is required. And when it comes to conventional, now which are to do the filtration of pollens are there. As an example, protozoa, which is of greater than 2 micron meter size available, and microbial cells which are greater than or equal to 1 micron meter using required filtration of microfiltration. Similarly, viruses. Generally, for any disease, generally we say this is the reason or virus. That viruses generally are of size 10 to 100 nanometer. So they require ultrafiltration or microfiltration techniques. And similarly, hemoglobin, it is of 7 nanometer. So that is required still less size, no? So it requires filtration of type ultrafiltration. Similarly, H2O particle, that is of size zero point 0.2 nanometer. So it's very small, tiny particle compared to all. So it requires reverse osmosis filtration method. So the same thing is continued in the next slide, like filtration techniques, typical pore size or range, then what it removes if I use that kind of filtration technique. Then so generally where we use the application. So reverse osmosis RO. technique generally needs a filtration with the size range of zero point 0.1 to 1 nanometer, and which removes water molecules, that is contaminated water molecules or dissolved salts, ions, and which is generally used in water purifiers. Then similarly, ultrafiltration UF, that is 1 to 100 nanometer types of particles will be filtered. So there we can see to remove unwanted proteins or viruses. That will be used in the application like sterile filtration or removing macromolecules. And similarly, microfiltration is of the range 100 to 1 micrometer. That is to use to remove bacteria or some viruses. So in real applications, wastewater management or beverages industry like that. And conventional filtration, that is greater than 1 micrometer for the particle size. So protozoa, suspended solids are the examples where we can see the removal particles, and this will be used at household filters or air filters are the examples for this technique. Similarly, contaminant size, that is top arrows, just what we have seen in the previous slide. So if we start from smallest particle, that is H2O molecule, that is too little or too small, that cannot be easily go through from the normal filtration. That means that is very hard to identify the filtration of such kind of small molecule H2O. So it generally it passes all because the available filtration methods cannot stop such kind of tiny small. So we need to identify very different filtration methods for that. And then hemoglobin, that will be filtered or using ultrafiltration is of size 7 nanometer. Then viruses 10 to 100, ultrafiltration or tight microfiltration. Similarly, microbial cells are of size 1 micrometer, that will be used the technique of microfiltration. Then protozoa, that is 2 micrometer, that can be used to filter that using conventional filtration. Then when it comes to so what are the materials of nanotech? So if you see nanostructure and then size, and then what are the examples of materials or application if you see. So clusters or nanocrystal quantum dots are of size of the radius of 1 to 10 nanometer. Then these are seen in examples like insulators, semiconductors, metals, magnetic materials are all these available with this size. Similarly, other nanoparticles are of radius 1 to 100 nanometer. So that will be seen in ceramic oxides or bulky balls. Similarly, nanowires are of 1 to 100 nanometer, can be seen in metal semiconductor oxides and sulfides, nitrides, and nanotubes. So nanowires are different. Nanowires are like a stretchable strands, whereas nanotubes are like curved shape. So these nanotubes are of diameter 1 to 100 nanometer, whereas nanowires are of diameter 1 to 100 nanometer. But the application is different because nanowires are used for metals or semiconductors kind of things, real scenario. But nanotubes will be used for including filters or layered one after the other layered materials like that can be used. These nanotubes. Then